Hello and welcome to another lesson from Level Up Mathematics. In today's lesson, we're going to look at special products of binomials. Now, in mathematics, there's some multiplying patterns that occur so often that mathematicians have created some shortcuts that we can use when multiplying these special patterns. Before we look at the shortcuts, though, I want to look at some products that we're going to use an area model for. So in example 1, it says use an area model to find the product for each of the following. So in the first problem, we have x minus 3 quantity squared, which simply means we're going to multiply x minus 3 times x minus 3. So to do that, the problem has asked us to use an area model. So I'll cut this into a 2 by 2 rectangle, and we're going to multiply x minus 3 times x minus 3. So for an area model, you take your first term, x, and you multiply it by everything in the top row. So x times x gives me x squared. X times negative 3 gives me negative 3x. Then you take your second term, the negative 3, and multiply it by everything in the top row. So negative 3 times x gives me negative 3x, and negative 3 times negative 3 gives me positive 9. Then you want to look in your area model to see if you have any like terms that can be combined. So our final product here is x squared. Negative 3x plus negative 3x is negative 6x, and plus 9. So x minus 3 quantity squared became x squared minus 6x plus 9. All right, for our second square, we have 3x plus 4 quantity squared. So again, we're going to use an area model here. I'll cut that to a 2 by 2 rectangle, and I'm going to multiply 3x plus 4 times 3x plus 4. Because we're squaring it, we're multiplying it times itself. So again, I'll take this first term and multiply it by everything on the top row. So 3x times 3x gives me 9x squared. 3x times 4 gives me positive 12x. 4 times 3x gives me positive 12x, and 4 times 4 gives me positive 16. So my final answer here, 9x squared, 12x plus 12x, excuse me, I forgot to highlight my like terms. I'm combining those. 12x plus 12x is 24x plus 16. So 3x plus 4 quantity squared became 9x squared plus 24x plus 16. All right, now we're going to multiply the quantity a plus b quantity squared. So again, it's just like the other problems. I'm going to create an area model here with a 2 by 2 rectangle. I'm multiplying a plus b times a plus b. So a times a gives me a squared. A times b gives me 1. You can put the 1 there if you want to. 1ab. B times a also gives me 1ab, and b times b gives me b squared. Let me highlight my like terms because we're going to combine those. So we have a squared. 1ab plus 1ab is 2ab, and then b squared. So a plus b quantity squared became a squared plus 2 times a times b plus b squared. All right. On our last problem, we have a minus b quantity squared. So we're multiplying a minus b times a minus b. Pause the video and try this problem on your own. All right, welcome back. Let's see how you did. A times a was a squared. A times negative b was negative 1ab. Negative b times a is also negative 1ab. And negative b times negative b was positive b squared. If I combine like terms, I get my final answer to be a squared minus 2ab plus b squared. So I want you to notice something here. In every time we squared a binomial, we were squaring the first term, squaring the last term, and then something special was happening to that middle term. So look in our first problem. We had our first term was x, our second term was 3. And when we squared that, our middle term became negative 6x. So can you see that we multiplied it and then doubled it? You might see it better on the second one. Here we had our first term was 3x, our second term was 4. If you multiplied that and doubled it, you'd get 3x times 4 is 12x. And when I double 12x, I get 24x. So the square of a sum, a plus b quantity squared, is a squared plus 2 times a times b plus b squared. And if there's a subtraction sign in the parenthesis, it's the same thing, except for we have a squared minus 2ab plus b squared. Trinomials written in the form above are called perfect square trinomials. So when you square a binomial, you're always going to get a perfect square trinomial. Now, let's talk about what we mean here. In example 2, we have x plus 8 quantity squared. So I'm multiplying x plus 8 times x plus 8. And according to the pattern, I'm going to take the first term and square it. To get the middle term, you're going to multiply the first term times the last term and double it. So x times 8 is 8x. And if we double 8x, we get 16x. Then you take your last term, which is 8, and square it. So 64. All right, let's try that again. In problem B, we have x minus 7 quantity squared. So our pattern here is a squared minus 2ab plus b squared. So I'm going to start it the same way. I'm going to take my first term, which is x, and square it. So write that down. Now, to get your middle term, you're going to multiply x and 7 together. Just ignore the negative. X times 7 is 7x, and double it. So that's 14x. But because there's a minus in the parenthesis, we have to put a minus in front of the middle term. Now take your last term, 7, and square it. So 7 squared is positive 49. All right, in problem C, we have 4x plus 3 quantity squared. So since this problem has a plus in it, our pattern we're going to use is a squared plus 2ab plus b squared. So let's try this process again. Take your first term, 4x, and square it. So 4x times 4x is 16x squared. Now, to get your middle term, you take your first term, 4x, and you multiply it times the second term. So 4x times 3 is 12x, and then you double it. So that would be 24x. And then you take your last term, which is 3, and square it. So 16x squared plus 24x plus 9. Now, each one of those problems, we were squaring a binomial. Look at example 3. In example 3, we're not squaring a binomial, but we're taking in problem A, 5x minus 2 times 5x plus 2. So the same exact terms, except one is a sum and one is a difference. In problem B, we have 2x minus 7 times 2x plus 7. One of them's a sum and one of them's a difference. And in problem C, we have a plus b times a minus b. Now, before I show you the special pattern for these, let's multiply them out the long way with an area model. So if I used an area model for problem A, let me draw it first here. I am multiplying 5x minus 2 times 5x plus 2. So 5x times 5x is 25x squared. 5x times 2 is positive 10x. Negative 2 times 5x is negative 10x. And negative 2 times 2 is negative 4. Now I'll highlight my like terms that can be combined. So my final answer here would be 25x squared. Negative 10x plus 10x is 0. And then minus 4. So 5x minus 2 times 5x plus 2 became 25x squared minus 4. All right, let's try that again. 2x minus 7 times 2x plus 7. Let me draw my area model. 2 by 2 rectangle. So I'm multiplying 2x minus 7 times 2x plus 7. So 2x times 2x is 4x squared. 2x times 7 is positive 14x. Negative 7 times 2x is negative 14x. And negative 7 times negative 7 is negative 49. So here I'm going to highlight the like terms that can be combined. So my final answer would be 4x. Negative 14x plus 14x is 0. And then minus, oh, I forgot the squared there. And then minus 49. So 2x minus 7 times 2x plus 7 is 4x squared minus 49. All right, in our last problem, we have a plus b times a minus b. So a plus b, a minus b. So a times a gives me a squared. A times negative b gives me negative 1ab. B times a gives me positive 1ab. And b times negative b gives me negative b squared. Highlight my like terms. So we're left with a squared. 1ab plus negative 1ab is 0. And then minus b squared. So a plus b times a minus b became a squared minus b squared. Now look at these three examples and ask yourself, why do you think the middle term disappeared or zeroed out for us? Up here, we have a middle term in each problem, negative 6x, 24x, 2ab, negative 2ab. Here, our middle term disappears, and I want you to think about why that is. All right, hopefully you said it's something because you had a positive and a negative, and that causes the negative 10x and the positive 10x to zero out. All right, so our special pattern, when we have a problem of the form a plus b, a minus b, it will result in this, whoops, I need to have a pen here, that will result in the square of a minus the square of b. In other words, a plus b, a minus b is equal to a squared minus b squared. Now, the product a squared minus b squared is also known as the difference of two squares. The difference of two squares. Now, we're going to use this pattern in example 4, our shortcut pattern. It says use the difference of two squares pattern to find each product. So in problem A, we have x plus 6 times x minus 6. So we're not squaring anything. One is a plus and one of the terms is minus. So whenever that happens, we can use this this multiplication pattern, which says a squared minus b squared. So that simply means the first term squared minus the last term squared. So if I take my first term, x, and square it, I get x squared. Then I put a minus. Then I take my second term, 6, and square it. 6 squared is 36. So my final answer here would be x squared minus 36. All right. B, 3x minus 4 times 3x plus 4. So we have a minus and a plus. So we can use this special pattern again, which says take the first term, 3x, and square it. So 3x times 3x is 9x squared. Put a minus sign, then take your second term, and square it. So 4 squared is 16. So 3x minus 4 times 3x plus 4, 9x squared minus 16. All right, pause the video and try problem C on your own. All right, welcome back. Hopefully you put 5x minus 3 times 5x plus 3 is 25x squared minus 9. All right, example 5. This time, we're going to mix up the two special patterns, and hopefully you can learn to tell the difference between the two and how to figure out which one to use. So in problem 5, it says determine which type of special product each of the following represents, and then use the special product property to find the product. So in problem A, we have 2x minus 5 to 2x plus 5. So we have a sum and a difference. When we have a sum and a difference, the pattern we use is a squared minus b squared, which means square the first term, square the last term, put a minus in between them. So if I square the first term here, 2x times 2x, I get 4x squared. If I square the last term, 5, I get 25, and then put a minus in between them and box it in. So 2x minus 5 times 2x plus 5 gives me 4x squared minus 25. All right, problem B is a little different though. We have 3x plus 4 quantity squared. So literally this time what we're doing is we're multiplying 3x plus 4 times 3x plus 4. So we don't have a sum and a difference this time. We have a plus and a plus. So that's from our first page, which said if you have a plus b quantity squared, you're going to use this pattern, a squared plus 2ab plus b squared. So let's write that down. A squared, always write down the pattern you're going to use. This is the pattern we're going to use. A squared plus 2ab plus b squared. So according to this pattern, you square the first term, which is 3x. So 3x times 3x is 9x squared. Then you put a plus. Now to get the middle term, you multiply the first term, 3x, times the second term, and then double it. So 3x times 4 is 12x, and double that to get 24x. And then you put a plus, and then to get your last number, you square the second term. So 4 squared is 16. So 3x plus 4 quantity squared becomes 9x squared plus 24x plus 16. All right, problem C, 5 minus 2x quantity squared. So this time our pattern is the same except for it'll be minus. So a squared minus 2ab plus b squared. So this is saying take the first term, 5, and square it. Then the pattern's telling you to put a minus. Now to get your second term, you're going to take the 5 and multiply it by the 2x. So that would be 10x, and then double it. So that would be 20x. And finally, you square your last term. So 2x times 2x is 4x squared. All right, problem D. 5 plus 6x times 5 minus 6x. Now, this time we're not squaring, but we do have a sum and a difference. So when you have a sum and a difference, our pattern is a squared minus b squared. So you square the first term, 25, square the last term, 6x times 6x is 36x squared, and put a minus in between them. All right, problem 6. Write an expression for the area of a square with a side length of 3x minus 2 units. So here's what's happening here. We've got a square. Let me put indicating that all the sides are the same. The length of each side is 3x minus 2. So the area formula for a square is area equals side squared. So in this problem, I'm going to substitute something in for the side. And in this case, it is 3x minus 2. Now, when we square a binomial, we can use this pattern, a squared minus 2ab plus b squared. So I'm going to take my first term, 3x, and square it. So 3x times 3x is 9x. Now take your first times your last. So 3x times 2 is 6x, and double it. So 6x doubled would be minus 12x. And then square your last term. 2 squared is 4. So there's an expression for the area of that square. All right, example 7. Write an expression for the area of the rectangle shown below. So this time, The area formula for the area of a rectangle is length times width. So I'm taking 7x plus 8 times 7x minus 8. So this time we have a sum and a difference. When we have a sum and a difference, our pattern is a squared minus b squared. So take your first term, 7x, and square it. So 7x times 7x is 49x squared. Then take your second term, which is 8. 8 squared is 64, and put a minus in between them, and you're done. And that concludes today's lesson, multiplying special products.